So let's go ahead and get started. Our final talk in this morning session is by Jonah Gelbach, and he is going to tell us about testing economic models of discrimination in criminal justice.
Great, thanks so much. And thank you for having me at this really wonderful conference. I want to say, just by way of beginning, I'm traveling, so I don't have my usual setup, which is why it's sort of shadowy on my on one side of my face, and I can't seem to fix that. So given the situation where I am, so I apologize for that. I also managed to develop a pretty bad cold. I have a negative coronavirus test and I'm fully vaccinated, but I may start coughing in the middle of the talk. So I apologize in advance if that happens. Okay, so this talk is about my paper about, you might think of it as a kind of specification testing paper. It's almost a kind of over-identifying restrictions view of things. And I'll get into more detail as we go. I have basically three goals in this paper. So the first is to provide a relatively general development of the Becker model of discrimination in the criminal justice context. This is a little bit of an embarrassing thing to do, in as much as lots of people have used the model in this and other contexts, and I recognize that much of what I'm doing is essentially relabeling things that have already been done. But I think there's some value in doing so, because it allows us to collect several testable implications of the model in one place. You can see flavors of, or maybe all of, at least some of these results in other papers, but they're notationally specific or substantively specific. And it's not always clear, I think, how the practical relevance translates across settings. And so part of the goal of this paper is to do all this in one place so that we can apply these ideas more generally in the future. And then third, my idea is to do all of this in an accessible framework. I think one of the great things about some of the literature, and I'll talk about it momentarily, that's been developing in this area is the connections to the treatment effects literature. But that literature has some really thick and dense notation, and I think it's easy to get lost in it. And you know, maybe I'm just a dullard, but I have a bit of a hard time sometimes seeing all the connections. And I thought that there would be some value in putting all this together in a way that would be straightforward and easy for readers to see in one place. And I guess I should say as well, when I say show practical relevance in the second goal there, the paper actually does some empirical work. Most of it is essentially using either published work and giving a new gloss on it, actual published estimates in other papers, I'll be clearer about that later, or using data from other papers in order to show how these ideas could be used in practice. I did have a plan originally of doing a much more ambitious amount of estimation of my own stuff when I started this project, and for reasons related to data limitations, I just wasn't able to do that usefully in this context. So this paper has really become a sort of a commentary about how to think about these issues and a demonstration in light of other excellent thought-provoking papers, and a demonstration that these tests are actually useful and travel across particular applications. So a few words about the literature on measuring and testing discrimination. There's, of course, the Becker model itself, and I guess that dates to his 1957 work, but you see it all over the place in different areas, including a couple of works of Becker himself. And of course, the basic idea is that discrimination and bias are modeled as the result of decision maker preferences that are themselves a function of type. So the race of a motorist, if it's the stop and search context, or the race of a defendant in the pretrial release context. Those are the two I'll be focusing on with this paper. But you could think about it in the lending context as the potential lender and that person's race or gender or national origin or sexual orientation. This is the sort of general view, right? So the Becker model is based on the idea that there are just preferences that people have, and they could be biased. And That's a very different view from the statistical discrimination view that we've heard a bunch about in various sessions in this conference. And I'm not going to have much to say about statistical discrimination, except perhaps a little bit at the end when I talk a little about Peter Hull's very interesting paper, if I get to that point. So where did the current, the roots of the current stop and search area actually date to this paper by, in some sense anyway, date to this paper by Knowles, Persico, and Todd in the JPE in 2001, which I'll just refer to as KPT. And that paper was sort of responding to a lot of public outcry about data that suggested that Black motorists in particular were disproportionately likely, or at least way more likely than white motorists, all else that could be controlled for equal, to be searched when stopped by state troopers. So there were a lot of lawsuits in the 90s about this. A lot of data became available. And Knowles, Persico, and Todd developed this observation that, well, actually, if motorists are able to decide, if motorists are deciding whether to carry contraband in the first place in a way that's that sort of accurately takes into account the probability of being stopped, they have this, and searched, they have this startling result that there should be no difference at all in the hit rate, so to speak, the probability of being found to have contraband when you're searched. And the point of that was to solve an infra marginality problem, which dates to the Becker model. So the Becker model idea is at the margin, decision makers are going to optimize. It's a Becker model, and so Becker's view was that if you could observe marginal product in a hiring context, for example, then the fact of discrimination, if it really existed, would have to mean that that Black workers who were hired must have higher marginal product than white workers, all else equal. And the problem is that if you just compared wages, you're getting averages, right, of observable people. And so the Becker model is one that says things at the margin are the right way to test, whereas the data typically are limited to averages, or at least that was thought to be the case up to that point. So Knowles, Persico, and Todd then developed this really interesting two-sided model that has this implication that in equilibrium, there basically is no inframarginality problem. I'm slightly generalizing, but it's basically right. And so their test for discrimination was very simple. We just look at whether a group has, so for example, Black motorists who are searched have a higher probability or a lower probability of having contraband found as a result of the search. And if it's a lower probability than whites, then that would tell you that essentially Blacks are being held to a higher standard. They're responding to it, and that's evidence of discrimination, and otherwise no. And so the empirics of what they found are less important for my purposes than the fact that there was then a kind of a big literature. It's kind of funny, actually, to me, looking back, because I was sort of assistant professor at the time and thinking a lot about these issues. Looking back, this was the big question, was whether there's really any inframarginality problem, not the treatment effects literature and marginal treatment effects and all the things that have become controversial in this world since. So it's quite a different setting. Anwar and Fang have this very influential paper in the AER in 2006, suggesting that, well, even if you take as given some of Knowles, Persico, and Todd's ideas, there's still the problem that highway troopers might have preferences that differ to the extent that the race of the person being stopped differs from the highway trooper's race. And this sort of non-monolithicness could be important. And then they have this famous paper as well. There's many other papers in this genre. So that kind of plays out. And I think the end result was sort of, there could be inframarginality and nobody's exactly sure what to do. Almost 20 years later, we have this paper by Arnold, Dobby, and Yang, which has been very influential and has a really, truly profound insight. It's in a very different context, what looks like a different context, which is the pretrial release setting. So I think the paper actually refers to bail, although it studies release, not bail amounts themselves. And the insight, I think, that's really deep in Arnold, Dobby, and Yang is that There's a connection between the treatment effects literature, and I won't say much more about this because David Arnold's paper yesterday, his presentation did a lot to sort of talk about these issues. But the deep insight here is that marginal treatment effects and the treatment effects literature more generally have a connection to this kind of setting because you can think about the fact of being released pretrial as a lot like the treatment dummy or isomorphic to the treatment dummy in a typical treatment effects setting. And then you can think about whether a person is rearrested, which is defined to mean rearrested outside of jail while they're awaiting trial as the outcome variable. And since it has to be zero for those who are not released, by definition, it has to be zero. It turns out that a lot of the machinery of the treatment effects literature can be used, and they do so. And as I say, it's been very influential. They found empirical evidence that, taken at face value, indicates considerable discrimination against Black defendants relative to white ones, using data from Philadelphia and Miami. And it's a sort of tour de force analytically. I'm going to suggest that the empirical conclusions are harder to support in light of the points I'm going to make here. There's an ongoing debate between those authors, and I think it's ongoing anyway, and Kane, Mogstad, and Mountjoy. I'm going to just sort of put that debate to one side. I don't want to get into the details of that for today's purposes. Relatedly, there's the Arnold, Hull paper that David Arnold gave a very nice presentation of yesterday, and that paper focuses on relaxing the monotonicity and accuracy assumptions that Arnold, and Yang and the Becker model that underlies it, and also underlies what I'm doing, focusing on relaxing those assumptions that model makes. And Peter Hull also has this really great new paper that talks about what we can actually learn from marginal treatment. It talks about a lot of things, but one of them is what we could learn if we knew marginal treatment effects, and we found that they didn't satisfy a set of restrictions that I point out, that Kane, Mogstad, and Mountjoy point out, and I believe Philip Marks also does in his really interesting paper, and I'll hopefully get to the point of talking about those things. So it's a very active area. There's Philip Marks's paper. There's work by Feigenberg and Miller, which I believe is going to be presented later today, maybe right after this talk. And then the paper we just saw by Hubert and Little. So hugely active area on measuring and testing discrimination in policing and criminal justice. And my hope is that by developing some basic stuff about the workhorse model in this area, I can facilitate the ability of and the desire of empirical researchers to be thinking about model specification tests rather than just assuming models and then reporting results. Okay, so my plan for the talk here is that I'm going to develop the Becker model I'll really start with the pretrial release context, and then, assuming there's time, get to the stop and search context. And then I'm going to draw the simple connection of the model to the marginal treatment effects literature using the pretrial release context. So this is, in a sense, kind of redoing some of the discussion in Arnold, and Yang, which I'll refer people to read. But I think that there's some value in providing a sort of simple and precisely stated economic model as the background for this. And then I'll derive and talk about, more talk about than derive. I'll sort of explain the intuition for testable implications. And as I noted before, these are like over-identifying restrictions in the kind of IV two-stage least squares setting where, if the model's right, then there are implications of the empirical results that aren't imposed directly by the model. So they're more than just identifying restrictions. And so we can actually test whether the model is consistent with the data to that extent. One way to look at it is that it's possible to estimate some of the parameters of interest, whether the model is right or wrong. Therefore, those parameter estimates, because the model makes predictions about relationships between those parameters, may be used to test the model itself. And then I'll apply these tests in the stop and search and pretrial release context. That's what the paper does, and hopefully I'll get to all of that today. And I'll also turn to a discussion of what conclusions we might draw and what we might think about doing differently if the model is rejected. And happily, there's already a lot of work going on in this direction, as I mentioned, from the Arnold, Dobby, and Hull and Hull solo papers. Okay, so here's the Becker model in the pretrial release context that I developed. There's a bail judge, J, and that judge values the freedom of a defendant whose type is X. So there's just a bunch of characteristics, and they happen to take the value little x, think of that as a vector if you like, of this defendant. That judge values this defendant's freedom as delta J of X, okay? Now, given the observable things X, not given J, but given X, the judge forms some accurate belief about misconduct on the part of the defendant in the event that the judge decides to release the defendant. This is pretrial misconduct, which I'll say a few more words about in a moment, what I mean by that. And I'm going to define the probability of this misconduct as M. So little m is in between 0 and 1. What do I mean by accurate? What I mean is that it's the case that across judges, or if you like, within judge, if you imagine the same judge seeing many defendants of the same type, that the conditional expectation of the misconduct rate given the defendant characteristics equals the actual probability of misconduct given those characteristics. So, of course, judges could make mistakes in any particular case, but they're not systematic and they're true on average. Now, I mentioned a moment ago that the judge, given X but not J, the judge forms an accurate belief. What I meant by that is that judicial beliefs in this simple model are not allowed to involve like judges with different levels of ability or different variances of predictions, and a lot of the stuff that that David talked about in the Arnold, Dobby, and Hull paper yesterday. There's essentially a kind of monotonicity across judges that this implies, which is to say that judges that are more lenient will release all the same defendants as less lenient judges plus an additional set. So that turns out to be important in context. So let me leave that now aside and get back to this M variable. I said that I would say a few words about little m and rearrest. The measure here is rearrest pre-trial, and I'm just going to refer to that as misconduct. Of course, not every rearrest is for actual misconduct. Sometimes people are arrested when they shouldn't be. And of course, if there's discrimination in arrest-making behavior, then we have problems with this approach. All I'm going to do right here is acknowledge that point and then move on from it. It's a potentially important one that I think points to the fact that isolating one element of a sequential process and talking about discrimination in that particular part of the process could be very problematic if the set of things that get us to the next or got us to this node of the process are themselves subject to discrimination. So that's all I'm going to say about that point, but I do want to flag it. All this tells us that the judge is going to release the defendant if and only if the judge's valuation of the defendant's freedom, given the defendant's characteristics, exceeds the judge's estimate of the particular defendant's probability of misconduct. Now you might notice that M is not indexed by X. There's no loss of generality there. There's going to be a distribution of M that's conditional on X to account for the fact that misconduct expectations by judges will be related to X. So this is just a notational convention, essentially. Okay, so most of my analysis is actually going to leave race aside. I'm going to be looking within race and finding restrictions in the data, or restrictions that the model imposes on the data, pardon me, that are true even holding race constant, right? So there's no need to estimate bias for my purposes in order to conduct the kind of testing that I'm suggesting. So you may have noticed there was an absence of a race index in the previous slide, and that's why. So moving forward, as I said, the judge releases every defendant whose misconduct probability is below the judge's valuation. And now we can define the distribution I mentioned earlier, f of m given x, and we'll let that be the CDF of misconduct given what I'm now treating as a random variable of defendant characteristics, although throughout this analysis I'll mostly be keeping it, maybe fully be keeping it constant, given defendant characteristics x. So let's talk about Judge J's release rate for a type X defendant. It's the probability that the set of defendants in front of that judge have misconduct values M that are less than or equal to the judge's preference, which we've already talked about. Now, here I'm using a capital M in the top equation on the right-hand side, just to reflect that for a set of defendants, there's a distribution. We're essentially treating misconduct probabilities as a random variable. That random variable has this CDF f of m given x. And so the release rate for Judge J, given that Judge J is facing type X defendants, in other words, R of delta J of X, this thing right here, is equal to this F distribution evaluated, the CDF evaluated at delta J, the judge's preference. So everybody with a misconduct probability below that will be released. Okay, so I want to turn now that's the release rate. I want to turn now to two measures of what are typically called hit rates. And I'm going to talk about traditional, or what I also call the conditional hit rate, and then an untraditional, which I'll call as well the unconditional hit rate for a judge of type delta J of X. In other words, a judge who has that valuation of freedom for X type defendants. So the unconditional hit rate is, you can see here, is just defined as the total, think of it as the total mass of rearrests that happen for this judge post-release decisions by this judge. So the judge releases every defendant of type X who has a misconduct probability below delta J. And so it's the integral from 0 up to delta J of the misconduct probability times the conditional density of that misconduct probability in the population. It's just the sort of conditional expectation of the misconduct probability, given that that only those with misconduct probabilities below the threshold delta J are released. So that's this epsilon of delta J object. That's the unconditional hit rate, the mass of rearrests that a type J, that a judge of delta JX type will have. So I just said all of these things, so I forgot that I had that. So the traditional hit rate, by contrast, looks at the probability of rearrest only under those who are only for those who are actually released. Okay, so you can see the main distinction here by looking at the densities on the right-hand side here. The top one is a conditional density in the sense that it conditions on X, but it's unconditional in the sense that it doesn't condition on the misconduct probability itself. Now look at the bottom density, and you see this purple circle shows you that the density is conditioned on having a comparatively low misconduct probability, lower than the threshold. And that gives us the traditional hit rate. So we can rewrite that conditional density as the density from the top unconditional hit rate definition, the one that doesn't condition on misconduct probabilities being low, divided by the set of defendants who are actually released by a judge of this type. That's the release rate that we developed in the previous slide. And so this is just another way of writing the conditional density from the previous version, right? So the unconditional one divided by the release rate. Now, by taking the integral over here and observing that nothing in the denominator, the R of delta J, involves the misconduct probability, we can essentially factor that out and then write everything else as if it's in the numerator. And what we get then is the ratio of we see that numerator is the same as the unconditional hit rate, the mass of rearrests. And so the end result is that we can write the unconditional hit rate as the product of the conditional or traditional hit rate, the H thing, right, which is the share of released defendants who are rearrested. So the share of all defendants who are rearrested is just the product of that traditional hit rate times the share who are released. That's just by multiplying both sides of the bottom equation by the release rate. And I kind of go through this here just to point out in the paper, it's useful because it's helpful for understanding some of the testable restrictions. But here, I'm doing it just to point out that if all you did was look at the traditional hit rate, in other words, the rearrest rate among those who are released, if that was all you did, then you would neglect this aspect of the problem that involves judicial decision-making in deciding whom to release in the first place. So if you look at H only, you're not paying attention to R, and that's an important part of the set of things that judges are doing. And so unless you could come up with some test for discrimination that accounted for possible differences, say because of differences in the F of M given X distributions across race, then you'd have problems, okay? All right, so that's a reason to suggest that this unconditional hit rate might be a place to look. And I'm not going to get into great detail. I'm going to get into a small amount of detail about it in a second, but just a foreshadowing that ADY actually, Arnold, Dobby, and Yang actually look at what you might think of as or should think of as an analog to the upsilon, to the unconditional release rate, because they're looking at, they're essentially running IV regressions where the left-hand side variable is a dummy for being rearrested without conditioning in defining the sample, without conditioning on the event of release. And that's faithful to the point I'm making here. So this is, their paper came first. So my point is that what they're doing in that sense makes a lot of sense in this context. All right, so let me talk about how we might, in this model, identify judicial preferences. It's surprisingly easy. The trick is to take these two equations, the one defining the unconditional hit rate and the other defining the release rate. Imagine we hold X equals little x constant. So we just look at a fixed type defendant. And we move from a judge who has a preference for valuing the freedom of such a defendant equal to delta J. We think about moving to one who has preference delta J plus D delta, just a differential little infinitesimal move. So the first question is, what would be the impact on the mass of rearrests? Okay, well, take differentials of both sides of that top equation, and don't be fooled by the fact that delta J is a function of X. We're holding X constant here, so it's not unreasonable to think about differential moves in delta J. And if we take differentials of both sides, just the usual differentiation rule for an integral gives us this result that we just take the limit of integration, delta J, insert it where M is, and that gives us the right-hand side here. And then, of course, we have to multiply by the magnitude of the differential here, the D delta. Okay, what about the impact on the mass of releases? If we move in the judge distribution to a slightly more lenient judge, we'll get an increase in releases because we're moving from a judge who releases only those with misconduct below delta J to a judge who's willing to release not only those, but this additional set between delta J and delta J plus D delta J. And so whatever the density is at that limit of integration point, multiplied by the differential is the increase in the mass of releases. Now, if you look at this for about half a second, you'll see that the conditional density, or the densities, I should say, multiplied by the D delta terms appear in both of these things. So the natural thing is to take their ratio, and what you get out of that is that the judicial preference delta J of X is identified by the slope of the unconditional hit rate function with respect to the release rate. Okay, so that's a kind of, I don't know if there's such a thing as a hand-waving formal demonstration, but if there is, this was that. You could do it more, and I do in the paper, more formally by defining things a little more precisely, but it's the same basic result, and this gives the intuition. Why does this matter? Well, there's a connection to the treatment effects literature, and I had the benefit of thinking about this after I read Arnold, Dobby, and Yang, who draw that connection. Although they don't provide this kind of precise development within a kind of fixed model. So I knew that the relationship was there, but I wanted to think about how to think about it more precisely. So I don't have like all the equations developed here for today's talk, but you can see the intuition for it as follows. Think of the unconditional hit rate, the upsilon, as the conditional expectation of a rearrest dummy. That's y, right? That's this dummy variable y. Given the characteristics of the defendant and x equals x, and then that there's a release probability, which I'll just call p so as to not constrain its value. There's something in the chat. I just want to make sure.
It's just me, Jonah. Don't worry about it. It's a question from the end.
Okay, got it. Sorry. Great. So you can think about this unconditional hit rate function as essentially the conditional expectation involving the rearrest dummy given some stuff. The stuff is important in the treatment effects literature. And now we know that the derivative of the unconditional hit rate function with respect to the release rate is the judge's preference for that defendant. But if you think about differentiating this conditional expectation that I just put up, that expected value of y, et cetera, you'll realize that taking the partial derivative of that with respect to p just returns the local IV estimator, defined in Heckman and Wittlissel's various papers, and that's the local IV estimator for the point where the misconduct probability is just equal to the judge's threshold for release. In other words, this is a marginal defendant. Further, Heckman and Wittlissel show that this local IV estimator equals the marginal treatment effect for the marginal defendant I just described. And so right there we see this this nice connection. And I just will add further that in the present context, as Arnold W. Yang appropriately point out, there's no rearrest if a person is detained, and just by definition of what rearrest means in this context. And so actually the marginal treatment effect, instead of being the difference in the conditional expectation of the rearrest when released minus that when detained, because the y when detained is always 0, it's just this expected value of y1, and actually that's pretty closely connected. I think it is actually the hit rate essentially here, the traditional hit rate here as well. So you can see a lot of connections in these models. Okay, so recapping what we've got so far, in the Becker model, preferences are identified by judicial preferences are identified by the slope of the unconditional hit rate function with respect to the release rate. I didn't have to say anything at all about the treatment effects model to derive that, right? I just wrote down a very simple Becker model and got to that result just by using the structure of the model. But it happens to be true that this slope is identical to the local IV estimator, which itself equals the marginal treatment effect under some conditions, monotonicity, and so forth. The last thing I want to say, though, is to hold in mind that marginal treatment effects are defined, they're features of a distribution, right, of a joint distribution of things, of random variables. They're defined whether this model is right or wrong. So you could do the thought experiment of somehow estimating marginal treatment effects without imposing the model's structure. Those two things you don't need model structure to estimate marginal treatment effects, although you do need the model structure to get the result that the thing I talked about, the slope of the unconditional hit rate function, works out to be the marginal treatment effect, right? So those are just distinct things analytically, and I just wanted to make sure to mention that. One implication is that if the model is rejected, but you have good estimates of the marginal treatment effects, then you might still be able to say something useful. I'll try to return to that point. Okay, so what about these restrictions I keep telling you about? So I'm not going to go into great detail about them because they're at least two of them are pretty obvious once you start thinking about it this way. I showed that there are three sets of restrictions that hold under the Becker model. So one is what I call a boundary restriction. There's actually two versions of it, but this is the more interesting one for today's purposes. Consider a set of defendants that are never released, right? So X-type defendants, and like the judge is just a particular judge is just never going to release a defendant like that. Well, that tells you that the judge must put a value of, and sorry, this is assuming there's full support on the misconduct probability distribution for type X defendants. That tells you that that it must be that the judge just places non-positive value of freedom on those defendants' freedom. And I mention this only because it turns out that if you look at Arnold, Dobby, and Yang's estimates, they estimate that on average, judges place a value mapped into the right space here, so the deltas are in the right on the right scale. That the average delta for delta J for Black defendants in their sample is something like 0.014. It's very low, you know, whether the standard error I think is big enough to include zero. Whether you say that that's a zero or not, I don't want to go into great detail about that. But if you thought of that as a zero, then that would tell you that well, if judges really place zero value on the freedom of those defendants, then there shouldn't really be any released, at least of those who have positive probability of misconduct. And there is some misconduct among those who Black defendants who are released in that data. So I don't think that the Arnold, Dobby, and Yang results necessarily reject this restriction, because we could talk about sort of what fraction there could be heterogeneity in the probability of misconduct and so on. But it is interesting to think about that if we get towards that boundary of having zero value of freedom, then anybody with a positive misconduct probability won't be released. And then this is a sort of a converse statement of that. So that's all I'm going to say about the boundary restriction. The association restriction, there are actually various implications, and if I have time in the stop and search context, I'll get back to them. I suspect I'm not going to have time. But I just want to talk about one of those restrictions for now, which is that there should be a strictly positive relationship between judicial preferences, delta J of X, and the release rate. This is almost tautological, right? I mean, it's very clear because if you have a higher valuation of defendant freedom, then all else equal, you ought to release more defendants, right? Two judges who see the same set of defendants with type X characteristics. If one of those judges is more lenient than the other, then that judge, almost the definition of leniency, right, is that delta J is higher for that judge, so they should release more, and therefore the release rate should be positively associated with judicial leniency. And here is a picture. This is figure 2 of Arnold, Dobby, and Yang, where they have marginal treatment effect estimates on the vertical axis, and on the x-axis is the release rate. Now, if the model is right, if the Becker model is right, then the marginal treatment effect estimates are the deltas, right? We've already just been through that. And so there should be a positive relationship between those. Now look at this thick black curve here. This is the marginal treatment effect estimates for Blacks. And this is the sort of set of point estimates, or the curve estimate, I guess. This thing should be monotonically increasing up to sampling variation if the model is right, and yet it's not, right? It's actually flat. I mean, I think that's the best way to describe it. If you look for whites, that's this thicker dashed line here. And it does kind of seem to increase a little bit, and then it kind of monotonically from about this point forward decreases. You know, these other things you see are I think point-wise standard error or confidence interval curves, confidence interval limits. So it's clear there's a lot of imprecision, but I think it would be very hard to look at this picture and say, well, the marginal treatment effect estimates in Arnold, Dobby, and Yang satisfy the positive association restriction between preferences, which is what marginal treatment effects are under the model, and release rates, which is what you see on the horizontal axis. So that's a second example and how it applies in one influential paper. And another point about Arnold, Dobby, and Yang's empirical results involves what I call the inframarginality restriction. And of course, inframarginality as a concept is kind of what's been at the heart of a lot of the methodological debates with the Becker model and the difficulty of estimating things. But it turns out that once we have the machinery necessary to estimate judicial preferences, we can actually use inframarginality as a test of the model. This hadn't really occurred to me until I started thinking hard about this paper and Arnold, Dobby, and Yang's paper. So we know that Judge J releases defendant X if the judge has a higher preference for valuation of freedom for that defendant than the judge's estimate of the misconduct probability for that defendant. And it's this like incredibly simple observation that if you take a set S of actually released defendants, it must be true that just run the expectation operator through both sides of that inequality. It's a monotonic function, and therefore it has to be a positive function. It has to be true that the average valuation of freedom among those who are released exceeds the average misconduct probability for the judges deciding whether to release those defendants. And under the assumption that judges have, on average, accurate beliefs, and throw in a law of large numbers, the expectation on the right-hand side in this box is consistently estimable by looking at the average rearrest rate among the set of defendants in question, and that's easy to estimate because the rearrest variable is just a dummy variable. So here's the results for white defendants from ADY's table 4. They have an estimated average value. I think these are the IV estimates, the 2 SLS ones, but the same point would hold. They have an estimated average value of defendants' freedom of essentially 24%. This is mapped into the right scale for this question. And the share of white defendants who are rearrested after they're released is 17%, right? So the thing in the top box is the expected value of delta of X for these defendants, and it exceeds the thing in the bottom box. So far, so good, right? They passed the inframarginality restriction for white defendants. What about black defendants? Well, the average value of defendants' freedom, I already mentioned this, for black defendants, according to their estimates, is basically 1.4. So that's equivalent to the value, the cost of a misconduct probability of 1.4%, taken at face value. But the thing is that 18% of black defendants who are released are actually rearrested. Now, that obviously violates this inframarginality restriction. It's hard to understand why judges would be, who place such little value of freedom on these defendants, would be releasing defendants who had such a high probability of committing misconduct. And so this is just not consistent with the model's restrictions. And there's a different question, which is what to do about that fact, and what inference to draw from it. But I don't think the fact is arguable. Now, Arnold, Dobby, and Yang have pointed out to me, which I had missed, that there is a footnote in their paper, I think it's footnote 14, that flags this issue. Their description of what this means is that judges have preferences that mean that judges are making mistakes. I think arguably a better description is we don't know if judges are making mistakes because an alternative explanation is that the model's wrong, because the model assumes that judges are behaving in a particular way, and these results are inconsistent with that assumption. So we can talk about what that means, but that's my view of the question. All right, so why do ADY's results fail these specification tests, if you agree with me that they do? So there are kind of two sets of possibilities. The first involves empirical misspecification. I don't have time to get into the details now, but my attempts to look at the code that they posted on the Dataverse site and compare them with the method of Heckman and Urzua and Wittlisel that I I think that they were intending to do suggests that there are some differences. And so I think it's possible that that what they're doing just wouldn't be expected to recover marginal treatment effects. This is a very provisional statement I'm making because I haven't had a chance to, you can't get the data because it's no fault of their own, it's restricted use data. And we're still sort of talking about this issue. So, but that's provisionally, I think that that's at least a real possibility. That it just may not be that there's a model where the estimates they're reporting are interpretable as marginal treatment effects. Let me say, hearkening back to a point I made earlier, remember I said that the model could be wrong, but marginal treatment effects estimates could still be right? Because you don't need the model structure in order to estimate marginal treatment effects consistently. So everything I just said about empirical misspecification is important because if Arnold, Dobby, and Yang's reported marginal treatment effect estimates are valid, if they're consistent estimators, then it definitely rejects the model, but maybe there are other things we could learn from them. On the other hand, if those MTE estimates are not valid, then the things that could be learned from marginal treatment effects, even in the absence of the Becker model, would not be ascertainable here. So it's an important question. It's not an academic one, which it is. Okay, so a second set of possibilities for what I view as this failure of the specification test is that the Becker model is wrong. There could be non-monotonicity in the way judges behave. Judges could have inaccurate beliefs in a kind of systematic way that constitutes bias. Those issues are addressed in ADH, the paper that David talked about yesterday, and really nicely addressed by Peter Hull's paper. And he has this nice result. I can't recommend strongly enough, at least the beginning of that paper is, the whole paper is good, but the beginning is particularly accessible. And when you get to table 1, you see a kind of a 4-cell comparison of, well, if you see outcome tests like the ones we're talking about violated, what you should believe depends on whether marginal treatment effect, whether the set of marginal treatment effects is increasing or not. The world in which they're not increasing is one in which kind of any Becker model or statistical discrimination model, I said I wouldn't say much, but this is one thing I'm going to say about those, any of those models has to be essentially wrong. And that means there must be biased beliefs, essentially. And so that's a really nice way of putting it. So if you credit the estimates in Arnold, Dobby, and Yang as valid marginal treatment effect estimates, the fact that they don't have the right slope monotonically is a strong indicator, maybe a knockdown indicator that what's really going on with their data is that the Becker model is wrong and there's biased beliefs rather than on average accurate beliefs. And that would be an important result to know. There might be some other problem in addition or instead of to this non-monotonicity and inaccurate beliefs issue. Maybe judges just act differently from the model or from how economists think they act. So sort of, I think a leading potential explanation here is that the model is one of pretrial release. You're either released or not. But what judges actually typically do is set a bail amount, or at least that's part of what they do. Some people are sent home on their own recognizance, and a small number might just be detained without bail. But if there are important differences in the important aspects of the setting of monetary bail, where judges are taking into account the probability that the defendant will make bail and so on, perhaps the decision problem is just more complicated, and so important aspects of it are being missed here, and that could explain things as well. A third issue that I haven't really thought through at all, but it occurs to me, maybe some judges have biased preferences, but are also sensitive to the legal norms of treating people equally, and maybe they don't always succeed, and that might be, in a sense, one way of explaining the non-monotonicity, or at least one aspect of it, or it might cause some other set of issues. So I think that one thing we should be willing to think about is the prospect of reconsidering how we model these things in the first place when we see rejections of model restrictions. So take-home points. It's possible to test the Becker model rather than just assume it. I think the model is a poor fit in at least some of the time. for two of the very important criminal justice settings that have, if not dominated, certainly been frequent subjects in economic research. And I think that points to the importance of new developments. The ADH and Hull papers are good examples. That's where I'm going to leave it now. So I'll stop and take questions.
Thanks so much, Jonah. It was a really interesting talk, seeing how some of the identification implications and econometric techniques tie in with criminal justice.
Thanks, Jonah. It's really, really interesting discussion. Not surprisingly, I agree with a lot of the points you're raising here. I wonder if you could talk a little bit about your point of view on this Panay Mogstad Mountjoy issue. I realize that you don't want to get too deep into the back and forth there, but one thing I did want to ask about is that you have these delta functions depending on sort of lots of characteristics, X, not just race. And my understanding of their concern is that like that's a problem for these kinds of tests when those thresholds might depend on non-race characteristics. And in the spirit of not getting too deep in the nitty-gritty, I think there's like this broader question of whether, you know, we should allow for bias and discrimination to sort of arise through non-race characteristics or not. And I guess that's sort of where I'm wondering where you're thinking about these things as you analyze these models.
Okay, great. Thanks a lot for that question. That's a very challenging question, so I'm not sure I'm going to give a fully satisfactory answer to it. But I have to go back and reread that paper. It's been a little while since I read it carefully. But you know, I think some of the back and forth I've read between those authors and ADY has been kind of hung up on the question of the definition of discrimination. So Panay Mogstad and Mountjoy have this definition that's essentially a sufficient condition. It's a pretty narrow one that they say there's, I was looking for the precise thing while you're talking. They say there's discrimination in the event, or racial bias, I should say, in the event that their version of my deltas is higher for one group than for the other, for all unobservable values, like for the full set of unobservable values given the X, the observed X. And maybe a different way to say it is X might encompass some things that researchers can't observe. And they say that there's bias if for the full set of unobservable values of the unobservable, the full support of values of the unobservable variable, if there's this kind of ranking. But if there are switches in the ranking, then they don't say that there isn't discrimination. I think that my conversations with other people have suggested that not everybody recognizes this. It's not like they're saying that there's only discrimination if that's the case. They're saying that that's a sufficient condition. And that's potentially important because the whole point of unobservables is it's hard to know what to do when things are unobserved, right? And so it's a kind of like almost like a stochastic dominance kind of style of definition. It's very demanding, right, to satisfy that. And I guess if I were going to attack my conceptualization of the Becker model or attack the suggestion that it could be useful, I would say, well, it's crazy to say that, you know, we observe every dimension of X that decision makers actually are paying attention to. And if we don't, then, you know, Gelbach, you go ahead and take your derivative all you want, but you won't have enough information to accurately estimate that thing. I think that's a totally fair concern. You know, at one level, I'm just describing what the model gives you as distinct from advocating for the model. But so that's a reason not to believe in the Becker model anyway, right? Even on top of everything else, I guess in some sense is the best answer I can give you. But I think it's also probably sensitive to context, right? Like if you have almost no information about defendants in the data set you have at hand, then it seems like the critique they're raising or the concern they're raising is a really empirically and practically important one. On the other hand, you know, if you have, I don't know, bail hearing could be a very, very short affair. There might be very little, it could be done by video. There might be very little information available to the judge that isn't also available in the data. There might be some, but not a whole lot. So it doesn't seem like it's obvious to me that the concern is always especially important. What I haven't gotten, you and I think have corresponded a little bit about this, or at least you sent me a question about this and I probably haven't answered yet. So you finally caught up with me. I think that the interesting question is, well, are there restrictions on the relevant functions under which we can learn things on average, even so, or something? And that's something I'm still thinking about. But that's already so far down the train of like compared to what Becker model stuff has been until this kind of marriage of kind of abstract Roy model stuff with Becker stuff that ADY helped cause, that I'm sort of less worried about it, I guess, than Canadian Extend and Mountjoy are.
Thanks. That's super interesting.
David Abrams, I saw your hands up.
Yeah,
Good to see you.
Yeah, you too. Feel better. My question is actually, I wanted to see your application of this to the traffic stops. It looks like that might not have enough time. So if you think it's useful to do any sort of high level stuff on the analogies, I'd love to see that, but I can also hit you up another time. And I have one other small question, which is, so traffic stops is where this has been used more than anything. Yeah, I think more than anything is right, but people use it for pedestrian stops as well.
Yeah.
Do you think there are any important differences there?
I guess that's a great question. I mean, I haven't thought that much about the pedestrian stops case because it's my sort of, when I've been thinking about this research-wise, it's been in data-wise in this context. But I mean, analytically, I don't know that there are any important differences. But I certainly, as a practical matter, seeing somebody walking down the street or standing on a corner, that might give you a lot more time as a police officer to decide whether to stop and search them than like somebody who's driving by a place where you're sitting in a fixed place, right? So you might have more capacity to observe things about them, e.g. race. So, I mean, I think, the taking a step back to the earlier node, should I stop the person in the first place? Right, all of this is usually about searches, not conditional on stop, not the stop in the first place, right? So in the pedestrian setting, there's probably more scope for discriminatory treatment in the stop node than in the vehicular setting, and that strikes me as potentially very important. So that's one example. Good question, though, and I should think some more about that. You mentioned the application of the model, so I think I can do this pretty quickly, and I'll give it a shot. So here's the trooper has a search distaste. So instead of evaluation of freedom, it's a distaste for search because search is time consuming or costly or whatever. And I'll just give it the same label as the valuation of freedom in the bail context, delta J. Then we have a motorist with characteristics X that could include stop characteristics as well, like where what road we're on and so on. Trooper forms an accurate conditional on release. It says release. It should say conditional on search belief about the probability that the motorist is carrying contraband. And actually, conditioning on search should be beside the point here, right? Because the contraband's there or not, whether or not there's a search. And then searches if and only if the misconduct probability exceeds the search cost, right? So that's really the only difference of note, is that the sign here is different. Instead of misconduct probability less than value of freedom, it's misconduct probability greater than search cost. And then we get a search rate as distinct from a release rate. So those play analogous roles here, except that they have a different sign, right? The sign in front of the F distribution is minus instead of plus here, for the same reason I just gave. But when you run through all the rest of it, you get all the same stuff. It's just the limits of integration are switched. Instead of 0 to delta, it's delta to 1. Because again, you search those with high misconduct rather than releasing those with low misconduct. And everything else just follows exactly the same. You take the derivatives of the unconditional hit rate function and the search rate function, and the ratio of those turns out to be the preference parameter, right? So you can learn all the same things. It's a little easier to, I have a little easier. I have slides that have developed the association restrictions in more detail for those, but I want to, I had the screen minimized. I want to check and see whether anybody has other questions before I go into that, because I hope that demonstrates for you, David, and for anybody else who's interested, how closely related these are, right? It's really just the sign on the on what we would think of in the treatment effects literature as the selection dummy, is just minus instead of plus. That's the main difference, and everything else follows.
So I was curious about how you think about the value of the Becker model here.
Mm-hmm.
So suppose we're in this world where we've rejected the Becker model, but we think the MTEs we're estimating are valid. This is something we've kind of thought some about with the project I'm presenting after the lunch break. But in what sense is like you could argue that MTE is what's relevant for policy, I guess, if you're considering, what would happen if we changed release rates or search rates by race. What additional value is the Becker model providing there in your mind? Like if it were true, what additional value does that provide?
That's a great question. I mean, so one thing that jumps out at me is you can estimate preferences, right? Like you could figure out what's going on, like what's motivating judges, and you could do it in the stop and search context at the stop level. You could do it in the bail release context at the individual defendant level. Like if you have enough data, right, so that we can do this, some sort of like semi or non-parametric estimation of this slope thing that we've been talking about. I can tell you the full distribution of decision maker preferences with respect to, conditional on race and conditional on X. And that might tell us really important things about where we need to direct our attention to try and equalize treatment, for example. That's just one example. I mean, I'd have to think some more. If the model's wrong, do we still get useful policy information from the marginal treatment effects? I think potentially, right? Like a lot depends on, there are so many Heckman and papers about all of this, and the sort of the weight functions are complicated and all of that. I should say that there's some space between the Becker model being wrong and the MTEs still being consistently or validly estimable, right? But it's also possible that, like, if monotonicity is violated, then like lots of approaches to estimating them will be wrong or something like that, right? Like, and so I think we need to be a little bit careful about thinking about, well, just because the Becker model, once the Becker model is violated, that gives us a particular model under which we know that the MTE estimates would be useful in this way. If it's violated, then a lot depends on kind of whether you think the rest of the structure and the Roy model kind of works out in a way that's usable. So those will be my two comments. That's a very partial answer because I haven't really thought about this. It's a great question.
Thanks.
You bet. Excellent. Thank you all very much. And I'm unfortunately going to have to miss some or all of the rest because of travel stuff. But this has been a great conference. So I'm delighted to have been part of it. And I'm looking forward to watching the video of the things I had to miss. So
okay, thanks a lot. Thanks, Jonah. Good
travels
and feel better.
Thanks so much. I appreciate both.